How do I integrate this following improper integral and tell whether it converges or diverges? Uh, this one is an improper integral because of the infinite limit we have here. Also, this one is gonna be a little bit complicated to integrate just because we have like a x squared outside of the e to the negative x. But that's simple. Like, we'll just go through it and you'll see how we work it out. Since this is a improper integral, we'll make it as a limit. So the limit as b tends to infinity of the integral from 0 to b of x squared times e to the negative x dx. So first we gotta integrate this using integration by parts. Therefore, we make f equals x squared and g prime equals e to the negative x. When we integrate this, when we differentiate this, we get 2x, and g will give us negative e to the negative x. Therefore, our integral will be equals to this, a negative x squared divided by e to the x minus the integral of 2x times e to the negative x dx, which will equals that. Now, how to integrate this? So we will have to do another integration by parts to be able to integrate it fully. So we integrate by parts this. We make f equals x and g prime equals e to the negative x. Then when we differentiate f, we will get 1. And when we integrate g of g prime, we will get g, which equals negative e to the negative x. And then our integral will equals a negative x times e to the negative x minus the integral of negative e to the negative x dx. As you can see now, this is simple since we got just e to the negative x inside the integral, which will give us negative e to the negative x minus x e to the negative x. Therefore, we have everything for our integration. We just have to plug in, and we will get that our integral will equals 2 times negative e to the negative x minus x e to the negative x minus x squared over e to the x. When we simplify all that and combine them in like a few steps, we'll get this final answer, which is x squared plus 2x plus 2 divided by negative e to the x. So we just plug in that to our limit, which will give us this, which is the limit as b tends to infinity of all this from 0 to b. When we plug in 0 to b, we'll get this, which will end up giving us the limit as b tends to infinity of all this plus 2, because this gave us at the end 2, and a negative times another negative will equals positive. Then when we distribute the limit, we'll get all this, and then we can evaluate term by term. So here we go. The limit as b tends to infinity of negative b squared over e to the b is 0. Why? Because e to the b increases a lot faster than b to the 2. Here we go again, and we got here the limit as b tends to infinity of 2b over e to the b will equal 0. Why? Because e to the b increases a lot faster than 2b. And almost our last one is 2 over e to the b as b tends to infinity, which is also going to be equals to 0 because e to the b increases a lot faster than the numerator. And finally, the limit as b tends to infinity of 2, which is equals 2. Therefore, 0 minus 0 minus 0 plus 2 equals 2. Therefore, our improper integral converges to 2.